I'll go ahead and... Okay, so we had a short presentation from advising to start off the class. Jumping into the video here. For those watching later, make sure you're registered. He pulled up his notes, and the people he didn't see on the roster, he said were already registered. So when you all check the video later, that should be covered. But if you have any questions, remember to reach out to advising. So on to our stuff this evening. There's still a few things that we need to look at, and I went back, I have a list of things, and I was thinking we haven't really done much with cameras yet. Right? Our camera needs to move. In particular, we've been doing most of our stuff in Unity, but we don't want this to be a Unity specific thing, right? The course isn't called game development with Unity. Our course is game development, and we just happen to be using Unity. Unity has a really, really nice tool for cameras that makes the camera follow so nice. So we're going to look at that at the end because it's really easy to use and it's Unity specific. So it's probably what you're going to use in this course. But before we get there, we're going to look at the just general logic for doing things like having the camera follow our player. So I'll go ahead and start Unity, and I grab that mouse if I need it. So I'll go ahead and start Unity and pull up some pull up an example to refer to as we go through this here on my other computer. That way I have a reference if I make a typo while I'm talking and typing at the same time. So there's a lot of different ways that this can go. So I have, you can jump over here on my other computer, going into Drive and pulling up some of my, some games that I've made in the past. And let's see, I'll do 2D first. We'll look at 2D and 3D follows. So create a new project, camera 2D. That sounds like a good name for it. Let's see. Well, I'll pull, and then while that's pulling up, what has a good camera? Oh, RPG. Several RPGs have things. This one I think does. Okay, that'd be a good one for the yeah, the one I pulled up, I wasn't sure which one I was going to pull up because I've got a bunch of things on the list I wanted to cover and was going back and forth, and now that it's time for class, it's like, okay, gotta decide something. Camera follows. So I'll pull up the pulling up the examples right now, and the first one that I opened was one that I remember now had a really nice zoom feature. So we'll look at that in the 3D example once Unity opens. Hopefully it won't take too long to open here. It's probably going to ask me to update. If it's taken this long to get started, it's probably trying to download an update, which we've talked about that before. You don't want to do any updates midway through something. Okay, there we go. So we have our game scene. We've done a few things with that, and our main camera is already there built in, but maybe our scene's a little bit different this time. I'm grab a background. I have some backgrounds on Drive I can use. These are just random rolling backgrounds that just kind of, the left side lines up with the right side. Sort of like tiles. This one will work. With that. I will stick this in the chat real quick so you can grab this. So here's just a random rolling background. One of those where the left side lines up with the right side. So if you just start that moving, it'll just keep rolling forever. If y'all wanted to download that from the chat room in order to follow along, and I'll go over to GitHub and download the same character from the other day. Because I probably should have left that on the computer so we could do something with it. I have to download this whole thing, don't I? No, I'll just do that. Nope, that's going to take forever. There's like 10 Unity things on there already. That's going to take forever to download. So I'll just go in Spreadsheet, Assets, and oh, not that one. This one work. Download. Still not downloaded. Save image. There we go. We looked at animations the other day. Probably should have downloaded that beforehand because continue loading in the background. It's going to be a while to download, but really for our example, just a background and a character moving in front of it will be enough. So drag in the background, y'all have probably seen that a few times, right? I'll kind of try to make it big enough. Is that out of the way? That might be out of the way. And we can see here the amount of space our camera looks at, but our world could be a little bit bigger than that, right? I'll zoom way out and kind of accentuate this, scale it 12 in the X direction. And that's close to 2, get some whole numbers there. So now our background is much bigger than the camera can actually see. If we drag a character in, well, for one, that's going to look really weird by the trees. So that'll probably work. So we have this character here that is going to walk around in front of that background. You all have seen that. There's lots of fancy ways to do that. Usually like some fancy tools, and most of the Unity tutorials will show you those. the easiest way to layer things in 2 dimensions is just use your z-axis. So you see our camera's at -10, then the character and anything happening at that level, I like to set that at 0, and then the background, set that at something like +10. Yes. Even though we're in a 2D situation, we still have the that z-axis. So with -z coming towards us, we can layer the things and adjust what is in front of or behind other stuff, which can also be important to do in scripts. If you're scripting the whole thing, I'll make this one bigger, 2x2, so we can tell it's different. And you have a couple characters, you might need an adjustment as far as if this one's like at this level in the 2D one, it should be moving behind our character, right? So just a quick little selection structure, check the y-axis and then use that to adjust the z-axis on your character to decide which one is in front of or behind the other one. That should be a fairly simple selection structure. Just check the y-axis, and because of the way we lay out our 2D things, at least the side views like this, the one that has the bigger y value should be walking in front of the other one, which in Unity would mean a negative z-axis or a lower z value. That just popped in my head as something that might be useful to share. For our situation, I'm just going to make a quick script to get this character moving. Things we've seen before. Create a script. Call this player. Oh, no, that didn't quite get the zoom thumbnails out of the way. If I open Atom, oh yeah, I'm just gonna have to keep moving the thumbnails like normal. So I can minimize them to somewhat small, but it still kind of gets in the way sometimes. So I'll just do a quick script here to get the player moving, nothing too fancy. Yeah, I'll just use the regular transform. We looked at the other day about movement through physics, which can give us better movement. Keep in mind, though, that once the laws of physics apply, you have other things like momentum and the amount of energy, and we'll talk about some of those things. Friction slowing you down, you might have to start adjusting the mass and drag on your character and stuff like that. That showed up in somebody's question the other day. The character wasn't slowing down enough because it was kind of like there was no friction on the character. So whenever the key was let go of, the character was still moving at full speed and would just kind of bounce around. But more friction, basically more friction or air resistance solved that problem. I'll just go with the easier one here of I'll just move the transform instead of doing all the physics stuff. So we can grab our horizontal and vertical axis. That'll be assigned the input.get axis for our horizontal. Pictures are in the way. There we go. Ver is the input manager. We'll get the vertical axis off that. And if the horizontal axis is not equal to 0, we'll create a new vector2. I'll call it position is a new vector2. which is almost like our old position. We'll have transform, this object's transform, the position it's at, and the X value plus the speed, that speed. So we'll add a little bit to it. And then our Y axis will just be the transform dot position dot Y, and we'll just keep that at the Y value it was. And then transform dot position, we'll get that new, just get that new one. So we'll just move it a little bit from where it was. Did I get any typos in that line? It was behind the thumbnails when I was typing it. Okay, we'll move it a little bit from where it was and in the horizontal and make that the new new position. And we can do the same thing for the vertical. So if the vertical key is being pressed, the same thing, only we'll add the speed time to the Y position instead of the horizontal position, which I don't know why I did both of them. I was only planning on moving left and right because the topic here is getting the camera to follow the character. Need a little more room there. Does everybody see how that is related to what we were doing the other day? The one the other day is going to be better movement because it uses the laws of physics, but you should see a lot of similarities here in what we were doing the other day. Our position is a vector, so instead of changing the velocity applied to the character through the rigid body, we'll just reach in and directly change that position. But again, we have to do it as a vector, not as a bunch of individual numbers. It's a whole bunch of numbers that all go together. So keep the old Y the same and change the X, and that's the one we're actually going to use for tonight's example. Got a little carried away with the other part. So save that, come back over here. Hopefully didn't make any typos. No error messages, so should be able to attach that to our character now and give it a test. Okay, that might be a little too fast. And so let's try 0.001. 0.01, that might be better. Oh, let's have a 0 now. Okay, that's a better speed. Our character moves back and forth. Wait. Oh, I made a silly mistake. We did do this the other day. So we just saw him moving to the right with no problem. But when I push the A key, oh, the speed still set at 0. I need to fix that. Put the speed in there. And now when I push the A key, it's going to the right. Anybody want to tell me what I missed there? I'll go back over to the script. Why do both of our horizontal axes move into the right? Anybody want to tell me? Do you notice what's missing? No guesses on it? Do y'all remember what the horizontal axis returns? If it's not being pressed, it returns a 0, right? That was what our check is. And when it's being pressed, it's somewhere between -1 and +1. So in order to move the accurate direction, we need to include that potentially -1, because both of them were not 0, so it activated it. But then we were only had the positive speed, so it was only going in the positive direction. So whenever you use the vertical axis, make sure you bring in those negative, possibly negative values from the axis as well. So save that and see if he moves both directions now. Similar to stuff we've seen before. I'm gonna change that speed so I don't forget again. 0.03 is probably good. Now, with an actual speed in there, if we give it a run, I'll push D, he moves to the right, to the left, down and up. Moves at angles if I push both of them. So it gets us around, but you'll notice it's not very realistic movement. Sometimes that's fine, right? Sometimes it'll be perfectly fine to just move around like that. Yep, I remember that game. The Atari ET game was mentioned in the chat room. That was a fun game, but that was an early one where the movements were like this. It's very unnatural, right? And we want to try to simulate physics accurately. Yeah. So you want to, the rigid body is better, but sometimes that will work, so we can do that. But then we hit another problem. It'd be fine if this was our entire game, but there's a bunch of background going off to the left. We might need to do some stuff over there. Or there's a bunch of background going off to the right. We might need to do stuff over there. But our camera, no matter what I do with the character here, you notice the camera's transform is still at 0, 0, -10. So that's sort of the first thing we want to address is getting our camera to follow the character. And Unity has some really nice tools. So we'll come back at the end and look at the really nice Unity tool. But first off, let's do a little script, the sort of thing we have to do in most of our game engines to deal with camera follows. So I'll create a C# script, call it camera, and feed in some instructions for the camera to know to follow our character around. Just the basics here, because we have a really nice tool in Unity and there's so much to cover. It's as normal. We're just kind of scratching the surface, making sure this stuff makes sense so that you don't if you'll look it up and look at a tutorial, you'll have somewhat of an idea of what's going on with it. So for our camera, there's a couple data fields we'll need. The first one should be obvious because we want our camera to follow our character. So we need some sort of target for that camera to be looking at, a focal point. I'll call it focus. That sounds like a good name. And we want to follow the movement of it. So in particular, we want the transform data from our other thing. So I'll make a public field so we can fill it in on the other side. Or again, if you want to use all private data, just remember to do serialize field. And then you can do that with private data as well. It's a little easy. I'll just stick with the public one the way we've been doing most things. And all we really need is the transform data from our character. I'll call it focal object. Give it a nice long name since that's the thing we want to look at, the thing we're going to focus on, the target of the camera. That would have been a good name for it too. The target that our camera is always going to be aimed at. Yeah, that should work. So anytime we move that target, we want to follow it. I'll set an offset. So in particular, we don't want to follow it exactly, right? We don't want our camera pressed up against it. If we're doing an FPS one, then we just make the camera our character. So that's what we move around instead of a character in front of it. But if we're following our character, we probably want to offset a little. So I'm going to make a public vector 3. Even though we are in a 2D game, I'm still going to make a vector 3 here and call it offset. And I know what this is going to be every time because I kind of want this to be the same distance. Kind of want the camera to always be the same distance from the character, except doing that will always give us a slight problem. We'll see here in just a second. I'll put the camera a little bit behind it, so might have to check numbers to see what works, but I'll start with like 1 behind it and 1 above it so that it's not centered on the screen. And well, this is a 2D game, so I'm just going to keep that camera at -10 the whole time. So we'll always be 10 Z units past our camera. Now that I see 10, that 1 might be a little small. I don't have anything in particular to do with the start method here. So most of it's going to happen every frame of the game. And what we're going to do is we want to set the thing we're looking at to the current position of where we're trying to go. So not public, a vector 3, because we want to move our camera to a certain position. I'll call it destination. The spot we're trying to get to, and that will be our focal object dot position, which is a 3D vector, but we don't want to be exactly on our character, right? Because, well, one of the things about the camera in a 2D one is we have that -Z so that we're always in front of the rest of the game. So we want to add to that our offset. Fairly straightforward. I'm going to leave a little bit of space there because there's something that it will work if we don't do, but we're definitely going to want to come back and put some stuff in that space after we see this move. And then we can just set our own position to that spot. Oh, did I skip that? Yes. Oh, we don't have to do a new vector 3 because we have 2 vectors. That was a great question. In the chat room, it popped up, do we need a new vector 3 like we did up here? Here, we didn't have any, there was nothing at all, right? When we just declare it, it's null. But here, our focal object, when we fill that in, that'll have a vector 3 with it. And we'll add it to a vector 3. So this is kind of like, to do a simplified example here, this is like if we had an integer, call it X, and that's going to be 2 plus 3 for our simplest case. 2 and 3 are already integers, so we don't have to create them in this case. We don't have to create it. And the same thing with the vectors. We already have vectors, so we don't necessarily need to create a new one. So I'm going to leave some white space. We'll come back and fill that in. And remember, when we add two vectors, we do component wise. So all of the X values add to each other, and then we get an X value separate from when we add all our y values together and our z values and all of that. So now we can just set our own transform position to that destination. And our camera should move there. A couple things we're going to want to fix though. But hopefully you see the basic idea is we're still just moving the object using a vector. In this case, a vector 3, because we want to make sure our camera is always back a little from our 2D scene. Oh, is that what you were asking about, Jacob? I missed a 3. I kind of caught that out of my the corner of my eye at the last second. Yeah, so we do need a vector 3, and then we'll just grab the position we want to go to and move there. Oh, sorry. Yes, that is correct. That was a typo on my part. We do have to say it's a vector 3. I thought you were asking about this one. Do we have to say we have a new vector that is all of those things? Because we would not get an error if we did that. We wouldn't get an error if we said new vector 3, but we don't have to in this case because we already have vectors. Sorry, I misunderstood the question. Uh-oh. Why is my error message like hidden? Oh, I guess I could look here. Cannot convert from double to float. Oh, that thing again. I forget that all the time. There it is right there. Remember, Unity always wants us to use the floating point numbers. So, but C# tries to default to double precision floating point numbers. Now, if we start moving, then that other step, which I'm sure everybody has forgotten at least once by now, right? The camera can't do that stuff unless we attach the script to that script to the camera. I'll give this a try. Oh, focal object. Yep. Everybody's probably forgot that a time or two now, right? The thing we want to look at. We'll look at our character. You all know the process. Put together what you think will work, fix the issues, and then go with it. So that works. But it follows our character. It's up and down. We might want to stop the up and down. That'd be a fairly simple selection, just a simple selection structure. And if else, just check your coordinates so your camera doesn't go past a certain spot. It's kind of jerky, right? Our character is going to be moving around really quick. But because by the nature of a game, the character is going to be moving very quickly. But when our camera moves very quickly, it's kind of dizzying, right? We want our camera to look more like we would get from Hollywood, right? Where you can think about the actor moving around quickly to show the action, and then a cameraman that chases after them, who happens to be an expert cameraman and knows not to be all jerky with the camera, right? So the best way to deal with that is linear interpolation. We're going to do some math, have the computer do some math internally to spread out that movement. So instead of jumping right to our destination, we can do a linear interpretation on it along the way. So to do that, we'll need a new vector 3. I left space for it. We'll just type it here. We'll create a new vector 3. I'll call it smooth movement. And in C# we can do linear interpolation, it's a Unity thing. We'll call a vector 3, the static versions from it, and LIRT stands for linear interpolation. which seems like a typo because interpolation does start with an I. But when they wrote that word together, I guess they didn't want to use an I for some reason. That's how we pronounce it. So linear interpolation, which instead of moving directly to there, we're going to stretch out the movement. And what we do, I'll add a public vector so we can adjust it, or sorry, a public floating point number. I'll call it smoothing. I'll start at half, 0.5, 50%. So instead of going right to it, we'll feed 3 arguments into the linear interpolation. The first one is our current position, as in the camera's current position. I'll copy it from there. The second one is the spot we're trying to get to. We want to move there, so kind of the same as that later line. We want to move, but interpolation, we don't want to do that movement all at once because that's what causes that jerking movement in the camera. So we can feed in a percentage. 0% would stay at the original position. It wouldn't move towards the new position. And 100% is what we would get with this line, where we move directly to that other position. So I'm going to start with 50% there. We can adjust it and find one that works good. So instead of moving all the way to the position on each frame of the game, we're only going to move halfway to the spot we want to get to. So if you think about that, you're going to realize that, well, if we only move halfway each time, our camera is never going to completely catch up with the character, which gives us a nice smooth effect. So that's the destination we want. Smooth movement. So to run this, well, you saw that first jerk, so as a move, 50% is pretty quick. Let's try like a quarter, 0.25. So that's still pretty quick. So you see, we usually want small numbers in there. Let's try an 1/8, 0.125. So our camera's not very far behind, but it's not necessarily completely caught up with the character. 0.0625, a 16th. Just cutting this in half. You see our character moves, then when he stops, the camera kind of has to catch up with it. That smooths it out. And then there's obviously a bunch of selections we need to do in there along the way. Let's try 0.01. That looks a little bit better, like our character can almost outrun the camera and it doesn't really catch up with him until the character comes to a stop. So our character can still do all those big jerky movements, but the camera is not quite so jerky, still a little bit. So we could check and maybe only follow in certain positions. So like I was saying, add some selection structures in here. So if offset.x minus focal object dot position dot x is bigger than so we're looking at 1.0. So if it gets bigger than maybe 3, we'll have to see what this looks like. And same thing for the y's, which I'm just going to copy. Not and. Or our y is the camera is more than 3 away from the y position. Then we will change this. I guess we can do all of it. We wouldn't really see a difference if these two things were outside of the loop, but when I went to copy and paste that up in there, or cut it and paste it up in there, it just made more sense in my mind to kind of keep them together. Oh wait, actually that would be a problem. Yeah. As I thought about that more, I realized that our camera is not going to move unless it's outside the selection structure. So we'll only change the spot we're trying to get to if we get too far away from the character. Otherwise, we'll just keep moving to that last spot that we know the character was at. Let's see what this looks like. Oh. Oh, not that. Copy that. And it looks like this is, in order to do this as a selection structure, since we might not create it now, that's going to need to be a global, something global. So now we got more wiggle room, right? Did I do my coordinates backwards? Oh. Geometry math have. Once we go negative, then we hit a problem there. But hopefully y'all see where that's going. Math f dot absolute value of the difference. If it's bigger than 3, then we'll follow. Oh, I have to look up absolute value. And we've seen this before. We're typing in C#. Remember, Unity does a lot of its own particular things. So always look at Unity first. Math f dot, oh, capital A. So that was just kind of silly on my part. I know the naming conventions these use. You all know the process, the general process, right? Always give it a try first. I usually say give 3 tries. I'll try 3 times. If I don't find it, figure it out in 3 tries, I'll look it up. Well, that went back to the jerky movements. So that selection structure didn't quite work. I'll go back to what worked earlier, because the core idea is there, but you'll want to mess around with getting some selection, finding just the right selection structure for your situation, because that's another one that it's going to change more than you would expect it to in a particular game. But you might want to adjust. And when we see the good tool in Unity, the good tool Unity has, it'll give you a better idea of what those selections need to be. So there's actually quite a few of them. This gave us the basic camera follow. So that's the general logic of what we want to do. We'll follow our character around, but remember that linear interpolation, because it makes the camera move a lot smoother. The action happens in front of our character without the camera suddenly jerking around everywhere. But again, like normal, those exact numbers are sort of a balance that you'll kind of pick a starting point and try to hone in on the ones that seem to work best. Okay. Like being able to outrun the camera is not so good. You don't want think about a Hollywood movie. You don't want your characters to outrun the cameraman and lose sight of them. But you want it to be, you don't want the camera to be as jerky as the player needs to be. 0.005. Let's see what that looks like. That looks a lot better. The camera is nice and smooth. Maybe some conditions, so we only go up so far up or down, or don't go too far. Doesn't look like our character can outrun the thing. And there's a little bit of balance involved in that. I'm gonna add a comment in here for 3D. I'll put a commented outline that when we're talking about a camera, or really on anything, but we don't use it much for stuff other than cameras. On our transform, we also have a look at property. So for 3D, we want to probably make sure and say, look at the target. So here's our general properties for cameras, the things we have, background colors, and adjust that to whatever we want, really. Make it look like a nightscape in the background, something really dark. Instead of that white, instead of that blue. Really, there should probably be a skybox in the background. But that's the basic idea for getting a camera to follow us smoothly. In Unity, we have a much nicer tool to work with. And the exact same, very, very similar code would work for 3D, and getting this follow to happen in 3D, you probably want to add in the thing to make sure you're looking in the right direction. In 2D, we don't have to worry about that direction, but in 3D, we do. So 7 o'clock, probably a good time to take a break, because this seems like a nice break point is before we look at the next little section. Does anybody have any questions about the camera follow? Okay, I assume the silence means no questions. Does 10 minutes sound good? Enough time to go grab a cup of coffee? I know I'm getting very thirsty. Any comments about a break? Okay, I see you in the chat room. So it is 7:02, so we'll get back to it at 7:12. I'll see y'all in just a moment.